Let's talk about another problem in one-dimensional kinematics. This one deals with the motion under free fall. The problem says a ball is dropped from a height of 90 meters on a floor. At each collision with the floor, the ball loses 1/10 of its speed. Plot the speed time graph of its motion between 0 to 12 seconds. The first thing we should know is that when the ball comes and drops and hits the floor, it loses 1/10 of its speed. Means if it's coming with speed v, it will lose v by 10 of its speed. So what is the speed remaining? 9v by 10. So it will go up by 9v by 10, come back and once again lose 1/10 of its speed, and like that it will keep on doing. Now we are supposed to find out the speed time graph between 0 to 12 seconds. So in this problem, we'll keep track of the amount of time spent so that we don't have our question extending for too long. So over here, before the first impact, let's analyze what happened. The ball was dropped above from 90 meters height and then it came all the way down and hit the floor. This was the first impact, right? Now before the first impact, 90 meters distance was covered. We are interested in finding two things: the time taken for the ball to come all the way down, that's first, and second, the velocity with which it hit the floor, because we know that 1/10 of that velocity will be lost. So first of all, I calculate the velocity using the formula v square is equal to u square plus 2gh. Now u is 0 clearly because the ball was simply dropped, and s is 90 meters because 90 meters is the displacement. The sign convention is downwards positive, upwards negative. So the sign of gravitational acceleration will be positive, and the displacement will also be positive because it's downwards. So using this formula, I obtain v1, or the velocity with which it impacts for the first time, as 30 root 2 meters per second, or also 42.42 meter per second. Now once I've obtained that, I am interested in calculating the time taken now, which can be calculated using h is equal to ut plus half gt square, correct, plus g because downward is taken as positive. If I calculate time using this, u have to be 0 and h has to be 90, t comes out to be 4.24 seconds. Now remember, I have to plot the graph for the first 12 seconds, and for the first 4 seconds have already been accounted. The ball hasn't even hit the floor, right? So it takes 4.24 seconds to come down and hit the floor. It hits with a speed 42.42 meters per second. Now let's talk about what happens when the ball hits the ground or impacts the ground. Over here you can see the ball will once again start going up, attain a maximum height, and then once again come back down. Now the problem tells me that ball loses 1/10 of its speed after every impact. So the speed with which the ball is projected upwards is simply 9 by 10 of the speed with which the ball came and hit the ground first. So v1 value is 30 root 2. The result comes out to be 27 root 2 meters per second, which means the ball is projected upwards with a speed of 27 root 2 meters per second after the first impact. This upon solving gives me 38.18 meter per second as my u value, or the initial velocity. Now I am interested in calculating the time taken to go up and come down, because I have to plot the graph for the first 12 seconds. For the first 4.24 seconds I already accounted for. I am looking for the next set of time. So if I use v is equal to u2 plus gt, correct, u2 is the velocity with which it's projected upwards, I can write 0 is equal to minus 27 root 2 plus gt, because at the maximum height velocity is 0, so final velocity is 0. U is minus 27 root 2 because upwards is negative, sign convention, right? My u value is taken as negative, and g is taken as 9.8. The result comes out to be 3.82 seconds. Now this is the time taken to go all the way up, meaning the total time taken for the entire path, which is up and down, is twice of t simply, which is 7.64 seconds. So now, by now, before the second impact, right before the second impact, total of about 11.9 seconds have already passed, right? Now the ball will come back and impact the floor for a second time, right? So what's going to happen? The ball will come and impact the floor and once again take off, but this time the height attained will be lesser. Then it will again come back and hit the floor, right? So between second and third impact, I can say that the ball will once again lose 1/10 of its velocity. So it will come down as 9 by 10 of 27 root 2, right? Because 1/10 is lost, so 9/10 is remaining. The result comes out to be 24.3 into root 2 meter per second, which is 34.36 meters per second. So that is the velocity with which the ball is projected after second impact, basically. Now the time taken to reach maximum height can once again be found as v is equal to u3 plus gt this time. u3 value is 34.36, right? The velocity after the second impact. the time value comes out to be 3.44 seconds, and the total time of flight is simply twice because the ball will go up and come down, right? Going up is 3.44, coming down is 3.44, is 6.88 seconds total time. Now you can see that after this calculation, we have crossed way past the 12-second limit that was given to us by the question. So by now we can start plotting the velocity time graph. Eventually we'll convert it to speed time graph. So look at the velocity time graph here. Now from here we can say that for the first 4.24 seconds, the ball was coming and about to hit the floor for the first time. There was a time taken for the first impact, you remember the result. And the velocity attained before the first impact was 42.42 meter per second, which is also 30√2 meters per second. Now you can see clearly that I have a straight line parallel. The slope of this line will give me the gravitational acceleration, right? And this graph takes into account the sign convention that we have chosen, which is downwards positive and upwards negative. That's why initially after t equal to 0, the velocity increases in the positive direction because down is taken as positive. Now the velocity increases all the way up to 42.42 meter per second, and then the first impact happens. Now after the first impact, 1/10 of the velocity is lost and the speed becomes 9/10 of the original value, which is 38.18 or 27√2 that we obtained. Now from 4.24 seconds all the way up to 11.88 seconds, which is 7.64 seconds more. That is the time we found when the ball takes to go up and come back, 7.64 seconds interval. So after 4.24, we have a 7.64 seconds interval, which is until 11.88 seconds. The ball goes up and then comes back. So the ball goes up, right? The velocity is becoming close to 0. At the top point, velocity becomes exactly 0. And then the velocity starts to increase in the downward direction, which is positive for us. Correct? And over here, we have once again the second impact, right? When it hits the ground again, goes up, comes back and hits the ground once again. There's a point of second impact. Now after this, once again, the ball will lose 9/10, the 1/10 of its speed and retain 9/10. The velocity becomes minus 34.36. Correct? This is 24.3 into square root of 2 value. Now and after that, once again after impact, it will go up, come at rest at the top height, and then once again start to come down. Bear in mind, this graph takes into account the sign convention where down is positive and up is negative. I am repeating it several times. Now once I have obtained this velocity time graph, I can very easily convert it to speed time graph because speed is simply, instantaneous speed is simply magnitude of instantaneous velocity, and speed is never negative. So whatever negative values of velocity we have in here, all we have to do is convert it into positive values, and there we'll have our speed time graph. So over here we have these lines which are on the negative side. We have to just flip it over, right, and it will give me my speed time graph, as you can see over here. It's very clear and straightforward. First of all, from t equal to 0, the speed of the ball was 0. Then it comes down at 4.24 seconds. Its speed is 42.42 meter per second, 30√2. It impacts the ground and then goes up. But velocity, in case of velocity, we had to change the direction or change the sign. In case of speed, no need of that because speed is a scalar quantity. We lose 1/10 of the speed. The final speed is 90% of the original speed, 0.9 times v1, which is 38.18 meters per second. Now after that, the speed starts to decrease because it starts to go up, comes to rest, speed becomes 0. Then once again speed starts to increase as the ball comes down, and once again second impact happens with the floor. Then once again 1/10 of the speed is lost, 9/10 is retained, the speed is 34.36, and once again the speed starts to decrease, the ball rises to maximum height and then comes down. So up to 12 seconds is somewhere right after the second impact. The graph is over according to the question, but we can continue plotting it. So as you can imagine now, this kind of triangular sort of structure will be repeated over and over again until infinity, because every time the ball will lose 1/10 of its speed. I hope this is very, very clear to you. Thank you.